I start? Hello, my name is Pedro. I'm a QA engineer at ClickHouse. I want to talk today about a topic that probably could let us make think for a while. That's something it might not be easy, which is fuzzing databases. I only joined ClickHouse recently, but has been already a huge ride and many things already happened. I just want to ask first if any of you know ClickHouse project. Okay, a few. Okay, thanks. For you that don't know, ClickHouse is an open source analytical database written in C++. It's known to be very fast for analytical queries and aggregations, as you can see, and can scale very well for one node to many, to hundreds. You have customers running. Running with petabytes of data. But what I want to focus here today is about testing databases, and because they are not as easy as you might think about. First, I want to just talk about fuzzers for a bit. I've been doing mostly fuzzing in ClickHouse for these past few months, and they have been a hot research topic, as all you know, for all these years. In many fields, in computer science, including security, but also databases. And we at ClickHouse, we also been, of course, targeted a lot over the years with many fuzzers, with all kinds of strategies to try and find all kinds of issues in ClickHouse. There are a few here. A few of them probably already know, like SQL Answer, which was pioneer to find wrong results. There are others like FAL and Fuzzer that are known to do coverage testing, to try to find new paths and find new issues with that. And the others less know that HT Fuzzer that we developed in ClickHouse ourselves. And there's this new one developed for ourselves called BuzzHouse that I developed in the past few months that was able to find lots of new issues. And all these fuzzers, they are not perfect. They can find some issues very easily, others not that easy. And this is what the point of this presentation, that there's not a perfect fuzzer to find all the issues in a database. But why? Well, as you all know, databases are very complex. They have to do lots of things, from query, optimization, and storage. They have to guarantee that data is always there, so even if the crash happens and it starts, everything must be there, running as smooth as possible. And there are many other things. Databases, they are known to have many interface languages, but SQL, which one is ClickHouse uses, is the most known one, and it's also quite extensive, and it has some complexity in there. And there are other things. If you run the fuzzer, that we have to make sure that the state is kept between queries, because a database has like a catalog with tables, columns, and data. And you must know that if you are going to fuzz something, you want to make sure, try to make sure that you are always targeting something and testing new code paths there. And it makes it more difficult that databases, they have to run for a very long time, like days or even years without interruption. And you also have to vary performance through time. And it makes it difficult to try to detect these things like in a more, I would say, automated way through a fuzzer. So what can we do to test a database with a fuzzer? Well, you can think about many things. You can start to think about, okay, we have SQL, we can try to generate SQL queries, but how? There are many ways you can do this. And also, you have to make sure that we are fuzzing something that exists there in the database, like a catalog with tables and columns, etc., many types. There are many things that we have to consider, and it makes it difficult to make this like in a random way with a fuzzer, because fuzzers are random mostly. And you also cannot make it very strict, because if the fuzzer makes very strict what can it generate, it can reduce the domain of inputs it can target and the issues it could possibly find. And also don't forget that not all the issues are just plain crashes. We have to try to find wrong results, performance issues, and etc. So things are more difficult to find. So there are many fuzzers out there that we tried also in ClickHouse and we have running on our CI. There are some like fuzzer that I told that does cover testing, but I think it's rather slow to generate inputs, and it takes some time, and you have to have a corpus that you keep in track in mind, and you have to keep it. It makes it a little slow. But I just want to show here the ST fuzzer that we developed by the ClickHouse a few years back before I joined. What it basically does is like it takes the inputs from queries from the clients or a test case where you have from ClickHouse and mutates the syntax tree to create new combinations and possibly find new issues. So I have an example here from the ST fuzzer. You create a table there, you are running on the client, and you find a query, and you'll simply start doing mutations of the query. You have here a select from a table, and you can see you can start adding a distinct clause. You could change the where clause, and now I'm also working to add join clauses, or change the type of query to explain or something like that. It starts by mutating, but this is rather slow because there's one fundamental reason that we have to give the input first to the fuzzer, and then he starts doing experimentations and try to find new issues. But he tried it by itself quite randomly, and also this is kind of slow that you will start from that input always, and you will start mutating it, and we are not sure if this input is probably the right query to find the next bug in ClickHouse. So let's then go back a little, and let's try to design the fuzzer ourselves. Well, because we are engineers and we do these things. I have just an example query here from the TPTS query 5, probably all of you know. Just to give some looks here. We have like a select with a from many tables. Then you have here a where clause with joining the tables. Plus we have a filtering clause there in dates. And then they have a group by with an aggregate, so you must follow the grouping rules, and then it's ordered by the end. So you can see already here this thing that you have to consider here. If you go completely randomly, we can get lots of errors, like if you miss these SQL grammar rules. And that's many of these fuzzers still fail on this. So let's then design one. Let's then think about something. I have a simple example here. Okay, the most simple one here. You have a probability here. From all the probabilities, you can either create a table, insert into it, delete, alter, or drop, or run a query most of the time. It's probably what you want. This sounds nice to start with, but there's already a few issues here. Probably you can already see if someone wants to try to give like already a comment on this. Oh no? If not, I can already tell there are issues here. First, we have a probability to add a drop statement at 5%. So at 20 statements, a drop statement will be generated, which means like a table probably cannot last like more than 20 statements, which is bad. And also, you have to look at the complexity of a created table that can be more complex with a drop because they have columns with many types and can have expressions there like for constraints and everything. Can be more complex to handle. So there's a chance that there will be many drops, successful ones, and very few create ones instead. And we probably end with no tables in the catalog, which is bad, and that doesn't happen in real life. And also, many of the deletes could delete completely. And the inserts could be complex because inserts must follow the rules of the table. And you can end up with empty tables most of the time, which also doesn't happen a lot in real life. So there's already some issues on this, and we have to think about in a way to avoid these issues and try to have a balance between what is completely random and what's more real-like. So I think there was something missing on LCI there in ClickHouse. So I came with BuzzHouse to try to fix this gap here. And this is what it does for now. 24,000 lines of code, which probably is a bit too much to a fuzzer. Lots of issues found, more than 100, and a lot of people busy fixing them. Probably it's already a good start. I only started this for a few months, and I was able to find many issues in ClickHouse. So what it does exactly? I could try to show a demo here, but probably there's no time to do it, so I'm going to stick with the presentation. You can find this with a blog post where I wrote about this. So the BuzzHouse in action just starts by creating some tables until a number and try to be more random and try to create as much correct as possible. And then starts generating queries, try to find issues, and make sure there's always a number of tables in the catalog. You want to keep always dropping them. Make sure some stay for very long to make sure that we have something to test on. Also, set a limit on the query size. You don't want to generate also many large queries because if the combinations are many, there are lots of chances that the queries won't generate anything useful. And try to generate like better inserts to make sure that the tables have something. And also, dump the session seed just if you want to reproduce it later, because some of these issues are not deterministic and they are more difficult to reproduce if you want to try manually. So sometimes you may just run the session again. So what BuzzHouse generates? Well, this is an example of a larger query. It's still not very close to TPCH query 5. Okay, I have a few jokes here because I'm also testing the new JSON type that we have for ClickHouse. And so we can have more identifiers than the table column and then subcolumn in the JSON. So it makes it a bit more complex. These are the larger queries. Sometimes I can also reduce some small ones. But I can start here some more closer patterns. Like we try to find like to make sure that all the columns used in the query used in the from clause. So try to be as correct as possible. Try sometimes also for something like the group by rules to make sure we have correct semantics. So we are able to find more issues. What I've found, as I said, lots of issues, crashes often, like segmentation faults, those undefined behavior things. They are probably the easiest to find. There are also the logical errors, which are kind of assertions in ClickHouse. So basically, like an assertion, like in a query plan or something that you must assert and then it fails. A few wrong results. There are a few ways. I'm going to talk in a minute how to detect them. A few. There was a few OM kills in ClickHouse. There are some issues in very edge corner cases about memory management, but that's not a big issue. And there are, of course, the queries that get stuck forever, never end. Maybe because there's a lock text or a bad loop that never ends. There's also not that common, but also happens. So what I do to find wrong results? There are many ways, a few, to find them. Some probably are more than the others. There's something as simple as that, as dumping a table and read back again and compare the content. It sounds a bit too simple, but I was able to find us lots of issues. Mostly in the data formats, because we in ClickHouse support lots of data formats like Parquet, CSV, Arrow, and all these formats. And the other things like running a query Oracle. This was SQL that actually started this a few years ago. We can do something like, for example, select count from a query with a predicate and compare it, the number of rows returned by that query with a select sum with that predicate, and compare then the number of rows of the first query with the result of the sum of the second one, and was also able to find a few issues there. There are more things more simple, like running a query with different settings, like parallelism enable or not, enable or disable external sorting, things like that. Was also able to find a few issues. And there are probably this one that probably more people like to think about is like comparing the results in another database. Comparing with the other ClickHouse versions is probably the easier way, because they have like the same SQL dialect. But if you want to start working with other databases like MySQL or Postgres, it starts to become a bit more difficult because the SQL language, as you know, it has some is not very defined in some ways, and some results are not may not be the same between the databases, and That's fine. It's just how they design. But BuzzHouse is okay. Nice. You find observation ClickHouse. That's great. But it also has issues like the other fuzzers. The first thing, probably as you can see from that BuzzHouse query, is that the combinations start to add up a lot. If you add a lot of things. But ClickHouse is like quite a large project. We support many things. By supporting many types, from integers to strings to nested types like arrays and key and values. There are also now your new JSON type. Oops, sorry for this. This is okay. Sorry, I wasn't expecting this. There's a new JSON type. You should also check the next talk. We're going to have another room about it. And they have many things, like many functions and settings, more than 1,000 of each easily, and that really stacks up. And they also have many table engines. Basically, engines is like defines how a table behaves. The merge tree is our most common one. Basically, is like a table that merges huge parts over time. So basically, we insert lots of huge chunks of data into tables and merge it over time. That's the merge tree in the basic sense. And they have some variations that to do, like some merge tree that to do like some aggregation combinations on it, but I will for later. And they also have more things, even like reading from S3 and even read MySQL data tables. So you have a lot of things. And also more, there are some other settings that can tune in tables. And you can also think about the ClickHouse in a multi-node setup. Like you also support replication, all these things. It becomes more complicated if you want to fuzz these things. And BuzzHouse then gets some issues from this. Because of these combinations, still many of the queries fail. I would say like more than 90% easily. The biggest issue here are these type of combinations that I'm not checking them, like comparing a string with an integer or with a tuple. Something like that, it's error. They cannot do that, obviously. Yeah, I could add checks for this, but it becomes more complex even to handle. And you can see the code base is already has some lines. Also, if I do something like performance, is also difficult. You have to generate like large tables to make sure like ClickHouse is using like out of memory to make sure that to find these performance issues. But it becomes difficult because some queries can be completely random, like cross products, and then it's slow, obviously, and there's nothing you can do about it. And then there could be some false positives from oracles. For example, I can optimizer my remove some part of a query, and that query could trigger a runtime error that the other part could not remove. And of course, they give different results, but success results, but that is expected. And there are other things that so far I don't change probabilities like of the actions, so maybe you can change these are runtime. And also I'm already locking the grammar of the queries, so I cannot generate like weird things or those obfuscated queries that some of these more some of the other fuzzers do, like OST fuzz or something. But it's already quite good. I already find many issues in ClickHouse. And as I said, this is more like a complement to it. And above this, there are even more questions that you can think about a fuzzer. What about running clients in parallel? Like database have hundreds of clients running at the same time. How are you going to synchronize all of them? Like what you are going to do? You have to make sure that it doesn't slow down the fuzzer and not create out of contention between them. What about fuzzing the server side? Like the ways to start the server or crashing or starting it is another thing. And if you have like more than one node, it becomes even more complex to think about. Then there are other things like size of the tables and the queries. How many columns should have in the table? Like thousands columns. Some customers of ClickHouse have these many large tables with lots of columns. And then you also check for the error messages. Sometimes they are legitimate, others not. So it depends on the case. It's difficult to track this. And there's also things that you should think about, like how long a table should stay in the catalog, because also probably you want to test another table with another combination that is more likely to trigger the issue. So maybe you want to swap at some point, but for long, you don't know. There are things that we can't find. So what's the conclusion? The conclusion is obvious. I won't be able to find all the issues like with one single fuzzer. There's still many things that you can think about there. And also, fuzzers usually they have the issue that you find some issues, and then after some time it stops finding new issues. So we have to think about them and changing over time. I could also add more features to BuzzHouse to counter this, but then the code base becomes quite complex to handle this. And I can tell you that fuzzers can also have issues on them, and debugging fuzzers is also kind of a weird experience, because you see like many queries running there, and then there's something you expect it to generate, but it never happens, but you don't know. Maybe because it's very rare to happen, or really there's an issue that it never generates. And it becomes a bit a nightmare to debug this. And also more features, we add more combinations, and then becomes less likely to have queries succeeding, or even the corner case that has a bug, it becomes with less probability to find, because they are more the domain is larger and there's more things to find. So what's the solution? Try to use as much as you can, like multiple fuzzers, different techniques, different tactics to test different invariants of a database. Try to find a way to, like oracles, to find more issues, like those I listed before. And you can also try to share like the code base between a fuzzer to another. If they are written in the same language, it's even easier. Like, for example, you can use BuzzHouse part of the query generation in htfuzzer to help it mutate, for example. You can do things, or use BuzzHouse output to htfuzzer and let it mutate and see if you can find anything else. We can try to do all these combinations between them to hopefully even to increase our chances of finding. So the solution I probably would like to have is have our CI crowded with fuzzers. Why not? We have all these different techniques here. FAL or fuzzer with coverage guided. SQL Smith, that is very known to manage very large queries. Also something left there. SQL answer for correctness. There's this one pstress that is not well known, but is known for generate heavy loads, like huge tables, like hundreds of clients running at the same time during real heavy loads. So that's why the pstress. And there's also this sysbench, which is more like a benchmarking tool, but it's nice to have it running for hours and see what happens. Like having that bug that you find after 20 hours, it's fun how to debug that. Yeah, is able to find that. And then they have some other things, others like htfuzzer and BuzzHouse for now to fill this gap and hopefully find other remaining issues, we hope. But there will always be something that we'll never find. So what I talk right now, I post a blog post on our company blog like last week, I remember. So you can always go check there, and there's some insights that I read there. Yes, I have other posts about other fuzzers, and I am done. So that's what I want to talk. But before I'm leaving, I just want to say that we at ClickHouse have a few people tonight. You're going to have a small dinner here at this address. We invite everyone to join us. I think there's going to be some snacks there, like beer and waffles, as far as I know. So you're all invited. So see you there. You can also talk about anything nerd related. So it's always fun to be there. So thank you, everyone. Now it's time for questions, if you have. Two questions, okay. Yeah. Anyone? No? Okay, one.
A lot of questions, so it's going to be hard to select one.
Yes. 3.
Are you doing
I'm doing part of ClickHouse development. Yes, we also have like new features being added. Some of these features I can add in them easily. Some others probably not that easy. So it all depends because ClickHouse now has many people working on it. So there are still a few people doing QA. So completely. But yeah, it just gives an idea. More questions there?
Yeah, about buzzing, what do you think about buzzing should be used only in nightly jobs or should be also using merge requests? Because in merge request
Mm.
if you do buzzing, you may find an error that is not related with the merge request and now the developer will have to develop something that you didn't touch.
Yes.
I don't know.
Actually, I can tell. Sorry, I can tell. I have a discussion with my manager about this like a few months back. Actually, for me, I would say more in a nightly build and create issues on the fly. Actually, in ClickHouse for now we have running as part of merge requests, and if the developer finds an issue, if the fuzzer finds an issue, he creates an issue, and for that anyone to look. But yeah, for me. Yeah, you can start the pipeline, yes, and see because still sometimes they don't find because they only run for short time. So sometimes you can be safe. Most I hope. No more questions. No more time. No more time. Thank you.